mainframe programming Miss Meyer. Shonda. Shonda Meyer, book of math.
Shonda's Monday math.
Okay, whatever. I'll ask about that whole thing again sometime when I remember where it's coming from. But yes, this is the ultimate exponent problem. It has every rule in it that we just talked about. So the question is, where do you start? Okay, I have several of you noted at the bottom right section, which this morning they went, man, those are really big powers. Till I got to the last power. What's anything to the zero power? 1. So that whole thing is gone, and that's a 1. Now, since I am multiplying it, since it's 1 times this other quantity on the bottom, I don't really need to keep writing it. If it was that quantity plus 1, you'd have to keep it there, because plus 1 would affect our value here. But since we're multiplying, we can just drop it. Now, where would you like to go with all of this? Okay, what do I have to take care of first? What order of operations do I have to do first? Okay, so parentheses, exponents, so do I start multiplying the two parentheses together?
You do equal and separate.
Yes, I have to deal with these exponents on the outside first. You got to do those exponents. So here's the question. Am I leaving this as 2 cubed, or am I changing it to 8? Look through your problem. Are they all going to be the same base? No. 2, 2, 2, 2. All your coefficients are 2s. If that's the case, leave it as 2. It'll be easier to combine it. Now, if one was a 2 and you got a 3 and a 5, then no, work them out to just ordinary numbers. But if they're all 2 to a power, you want that to stay as 2. So this will become 2 cubed. A to the what?
A to the 21st.
21st. B to the?
9th.
And C to the?
Negative.
There you go, negative 6. And then, same thing over here. Yep, to the negative 2nd, yes. A to the? Yeah, and a positive 8. Because negative 1 times negative 2 would be positive 2, and 2 to the negative 10. And while we're at it, let's do the bottom as well. That's going to become A to the? There we go. Okay, but are we done? Not anywhere close. So what would you combine next? I would multiply the two quantities in the numerator together first, and then worry about doing the up-down thing at the end.
Would you? That's what Miss Meyer would do.
So now that we're actually multiplying, they both have a base underneath them. What am I doing to the exponents? Now I'm back to rule number 1. Now I'm adding my exponents, so that is 2 to the first, A to the 21 plus 8 would be 29. B, 9 plus 2 would be 11, and C, yes, C is negative 16. And then I'm going to recopy the bottom here. And then last but not least, I can move things. Oh, you're right. Thank you. I did.
Good job.
So now, top to bottom, what am I moving? Okay, how do I bring, this is a 2 to the what? That is currently a 2 to the first. So if that's a 2 to the first, which one am I moving? I want to keep it positive. Yeah, I want the 1 to come down. So yes, 1's going to come down. I'm going to subtract 1, and so yes, I'm going to end up with 2 to the first on the bottom, or just 2. Now your A's, you want them to be positive. So yes, you want to get rid of the negative 14, so you might as well move it to the top. And it becomes positive 14, and we have, yes, A to the 43rd. B, since they're both positive, you just want to go, where would I move it to keep it positive after I subtract them? And I would, yes, go to the bottom. Subtract 11 would give me B to the 11th. And C's?
The bottom.
And yes, I could bring the 16 down, which would become a plus 16, and that would leave me with a C to the 6. Yes. Ah! Okay. I hit the wrong button. I just cleared the entire screen. But it's okay. Undo's a great thing. And there is our lovely final solution. Woo! It's a wavy box. You have an issue with my box?
It's not a rectangle.
Fine. We'll...
You need to put a picture around it.
I saw your magic. Black magic.
That's right.
She's a witch.
No, it's the magic of mathematics.
That's computer. There's no such thing.
All right, last thing we need to talk about here. I think you all know this already. I just need to make sure. You know this?
Yeah. Well, if your film makes you know it.
Yes. I will admit, I didn't have a lot of appreciation for scientific notation. I hadn't used it that much in math until I took physics. And in physics, it is key.
He explains everything weird.
In physics, you're either working with these giant numbers or these tiny decimals, and working with it in scientific notation is way easier than working with it with math. Okay, so let's do the basics first. Do you guys remember how to change a number into scientific notation?
2.43 times.
Okay, the question is, when you write that new number, how do you know where to put the decimal?
After one digit.
There can only be one digit left of the decimal, so this has to become 2.43,
Times 8.
and then, okay,
8.
and you're all out there doing little loopy-loop things, so, yes, you have to count from where it currently is. There's 1, 2, 3, 4, 5, 6,
Or you can use your
7, 8.
brain.
Or you can use your brain, hopefully, by this point, and yes, figure out that it is 10 to the 8. It's not going to get a whole lot more difficult, but we are going to actually apply a little arithmetic to it. But I need to double check. How do you do a number that's a decimal value?
You make it so that there's one positive number in the first digit.
Okay, 7.92. I need to move my decimal.
Times
Yeah.
negative 2.
Yes. Now, do you ever have trouble, or do you at least back in junior high getting confused about which way do I move my decimal? Is it positive or negative?
Negative left. I'm pretty sure you did it.
Okay. My rule of thumb is, guys, if it's a number greater than 1, it's going to have a positive power. If it's a fraction value less than 1, it's a negative power. End story.
What a way to look at it.
If it's a number, 243 million, is that greater than 1?
Yeah,
It's going to have positive power on it. 0.0792, is that less than 1? It's going to have negative power on it. That's all you got to know. So, because the problem comes in, you all knew which way to move your decimal here, but what if I give it to you in reverse? What if I give you 4.67 times 10 to the negative 5, and you're sitting there going, which way do I go?
It should be 4 zeros.
It's a negative power. It's got to be a tiny decimal. It's got to be less than 1.
Okay.
So we must have to go left with it. So hopefully you all learned that it's actually pretty easy. Stephen, stop swinging the pedometer and banging it into the desk. So you all have learned the fast way. When you're going with a negative power, you're moving at 1, and then it tells you need 4 more zeros in front. So 1, 2, 3, 4 zeros, and then a 4, 6, 7. So what is 5.8 times 10 to the 12?
Yep.
Actually, I was thinking first.
Make it a million.
It's 58.
Okay, it's a positive power. It's a positive power. It can't be 0.58. That's not greater than 1. Positive powers have to be greater than 1, so yes, it's 58. Now, what I really want, my whole purpose, and why is it in this section? Because we're going to multiply and divide them, and it requires us to use our rules of exponents that we just learned. Not anything too terribly difficult here. That's supposed to be 2.3 times 10 to the 6th, and we are going to multiply that by 4.7 times 10 to the 3rd.
So you do parentheses separately and then you multiply.
Okay, so my question is, how do you multiply that? And let me take you back to exponents. If I gave that to you as 2.3 x to the 6th times 4.7 x to the 3rd, how would you guys multiply that together?
You get x by itself.
You would multiply the, what are these numbers in front?
Base.
The coefficients. You would multiply the coefficients and do what to the powers? Add them.
The 10 is basically the coefficient.
So the coefficients are the 2.3 and the 4.7. 10 is your base. Yeah. So all you need to do here is multiply the coefficients, leave the base 10 alone, and add the exponent. So if you take 2.3 times 4.7, and this is where you may find a calculator handy.
Didn't we just spoil it?
That's, oh no, this is not foiling.
We do not want to foil.
That's not a plus sign in the middle, that's a times. Big difference.
I figured you could spoil it.
No, you can't foil that.
There's two binomials.
It's not a binomial because it's not a plus or a minus in between the terms.
Looks like binomial.
So then I would get 10 to the what?
9.
I would get 10 to the 9th. Is that a proper answer in scientific notation form? Can you have 10?
1.081.
Yeah. Cody, look live. So I would have 1. If I move it 1, we all know I need to change the exponent by 1. But the question is, do I go up 1 or down 1? Rule of thumb. You went from 10.81 to 1. Did that make that number get bigger or smaller?
Smaller.
We just made that get smaller, so therefore your exponent must get bigger. If the coefficient you made smaller, then that's got to go up and get 1 bigger, which would be 10 to the 10th.
Beep, beep, you're running out of time.
No, I'm not. I'm good. I got one more problem to do. But thanks for the warning.
Yeah, that's what I'm here for.
I can do it in 2 minutes.
That's your
Okay. With division, there's one rule. Scientific notation, your answer has to be in scientific notation form, so if it's division, you have to move everything up. You can't leave something in the denominator. So therefore, what do you think you're going to do to the coefficients out front? You're literally going to divide them, which is a half, 0.5. Yeah. So that's a half. Now, if the exponents have to come up, what's going to happen? Yeah. So if that comes up, you are going to have to bring it up and subtract 12, so you're going to end up with a negative power. But in scientific notation, negative exponents are fine. We like them in scientific notation. So that'll leave us with 10 to the negative 7. Is that an acceptable answer?
No.
I need 1 significant digit left as a decimal. So I'd have to move it over 1, which make it 5 times. Did I make it get bigger or smaller? I made this get bigger, so therefore that must get smaller, meaning you must subtract 1. So if I subtract 1 from the power, I would have 10 to the negative 8. So be careful of that. Okay.
Enjoy your math, dude.
I have posted the assignment sheet. There are lots of problems on the assignment sheet as well as in the book, so be sure you do mine on the assignment sheet because they're more exciting. Hope to see you all Wednesday.
How about you do